Question 4. The rate of change of the number of coyotes, N of t, in a population can be modeled by the differential equation dn dt equals k times the quantity 650 minus n. Solve this differential equation to find a formula for n. So for solving a differential equation, I definitely know the first thing that we would like to do is to cross multiply. So that's exactly what I'm going to do. I'm going to have dn over dt equals k times 650 minus n over 1. When I cross multiply, I will get dn equals k times the quantity 650 minus n dt. Before I take the integral of both sides, I do need to have both the like variables and like sides. So I need the 650 minus n over on the other side. So I'm going to divide both sides by that. So I now have dn over 650 minus n equals k dt. I'm now ready to take the integral of both sides. On this left side, since I have something in the denominator, I'm going to do a u substitution. So we'll let u equal 650 minus n, and then du would actually equal negative 1 dn. Notice I'm missing the negative 1, so negative 1 goes on the outside. So I now have negative 1, the integral of du over u, and I know the integral of du over u is ln, so it's going to be negative ln of the absolute value of u, and then equals the integral of k will be kt, and then do not forget your plus c. All right, we cannot do the logarithm loop yet because this negative sign is in our way, so we're going to multiply the entire equation by negative 1. So I'm now going to have the natural log of the absolute value of 650 minus n equals k negative kt plus c. Now I can do the logarithm loop. So when I do that, I'm going to get e to the negative kt plus c. And remember, we can just bump the c out front, and then we'll equal 650 minus n. And then to continue solving this for n, we are going to subtract 650 from both sides. So I will now have c e to the negative kt minus 650 equals negative n. And then to get rid of that negative, we'll multiply the entire thing by negative 1. And when I do that, c times negative 1 is still just c. So it'll be c e to the negative kt plus 650, and that will equal n. So I have now found a formula for n. Question 5, solve the differential equation 2x times the quantity 3y plus 1 minus y prime equals 0. The first thing that I'm going to do is to change that to dy dx. And I know if I need to cross multiply, I really need a fraction set equal to a fraction, so I'm going to add dy dx to both sides. So I'm now going to have 2x quantity 3y plus 1 equals dy dx. Definitely, if we solve a differential equation, I will be cross multiplying. Okay, I need to put a fraction, make it a fraction on the left side. So if I cross multiply, I'm going to get dy equals 2x times the quantity 3y plus 1 dx. I do notice that the 3y plus 1 needs moved, so I'll divide both sides by 3y plus 1. So I will now have dy over 3y plus 1 equals 2x dx. My variables are now separated, so I'm ready to take the integral. On the left side, since I have a fraction, I'm going to let u be the denominator. So u will equal 3y plus 1, which means du is going to be 3 dy. I'm missing the 3, so 1/3 needs to go on the outside. So I now have 1/3 the integral of du over u. And then from there, this will be 1/3 the natural log of the absolute value of u. So that's the left side. On the right side, 2x dx, if I just increase my power by 1 and do the reciprocal on the outside, it's going to be 2 times 1/2 x squared, and that will reduce to just x squared plus c. I cannot do the logarithm loop yet because I do need to get rid of that 1/3, so I'm going to multiply the entire equation by 3. So I'll get the natural log of the absolute value of 3y plus 1 is equal to 3x squared plus 3 times c is still just a constant. Okay, now I'm going to do the logarithm loop. So I'm going to get e to the 3x squared plus c, so the c bumps out front, will equal 3y plus 1. And now I just need to finish solving for y, so I'm going to subtract 1. So I'll get c e to the 3x squared minus 1 equals 3y. And then I'll just divide the whole thing by 3. So I'll get y equals c e to the 3x squared minus 1 all over 3. And now that is solved. Okay, find the particular solution xy dy dx equals ln x that satisfies the condition y of 1 equals 3. This is going to help me find my c when I'm done. Okay, if it's asking me to find a solution, I definitely want to cross multiply. So I need to make this side just a straight fraction and this side a fraction. So when I cross multiply, I'm going to get xy dy equals ln x dx. I notice that this x on the left side needs moved, so I'm going to divide both sides by x. So I'm going to have y dy equals ln x over x dx. I'm now ready to take the integral of both sides. On the left side, the integral of y will just be 1/2 y squared. On the right side, we can't just do anything yet. We're going to need to do a u substitution, and I'm going to let u equal the natural log of x, which would mean du is going to be 1 over x dx, which notice if I put a 1 there, I do have 1 over x dx. So when I go to rewrite this problem, u is up top and then everything else is du. So this is a u du. It is not du over u. Okay, just like what I did on the left side when I had y dy, I increased my power. I'm going to do that same thing on the right side, so I'll have 1/2 u squared plus c. And then I'll have 1/2 y squared. I do need to sub my u back in, so I'll have 1/2 y squared equals 1/2 the quantity ln x squared plus c. Do notice that I did put the ln x in parentheses because that's in the entire thing squared. And then I'm going to multiply everything by 2 to clear the fraction. So I'll get y squared equals quantity ln x squared plus c. I'm not going to square root quite yet because I usually like to find my c first. It's a little bit easier. So I know that when x equals 1, y is 3. So this will be 3 squared, which is 9, equals the natural log of 1 squared plus c. The natural log of 1 is 0, which means that c is equal to 9. So I've got y squared equals ln x squared plus 9. And then from here, we do want to get rid of the square by square rooting both sides. And really, we need to do y equals plus or minus the square root of ln x quantity squared plus 9. And then from here, I just need to decide, is it going to be positive or negative? And since this answer turns out to be a positive, we're only going to accept the positive. So my final answer will be y equals the square root of ln x quantity squared plus 9.